Hi, I'm Vishnu Sarukkai. I'm a PhD student at Stanford University, and today I'll be presenting our work, Collage Diffusion. Let's say I'm trying to use a diffusion model to generate a particular image I have in mind. In this case, I'm trying to make a bento box with rice, edamame, ginger, and sushi. I give a text prompt to the model, and it generates a few images for me. But it doesn't look anything like what I had in mind. Let me add some details to the prompt. I want this to be a top-down view with a white background. I want the sushi on the right, and I want the edamame in the top left. But this isn't quite working either. The diffusion model doesn't really respect the spatial constraints I had in mind, and there are a bunch of other details that are off as well. This iterative text-based approach could really take me a long time before I'm satisfied, if at all. So, what do I really want to express here? And how do I give myself controls to express my intent directly? For compositional images, objects are commonly controlled in artistic pipelines by decomposing a scene into layers. For instance, here's an example of some layers in Photoshop. We enable users to control diffusion-based image models and editing with layers. To make my perfect bento box, I first collect this set of image layers. Each layer contains information on the visual characteristics of the desired object and is paired with text. I arrange these layers in my desired spatial layout and pair the layers with a full image prompt. With all this information, the collage diffusion algorithm fills in all the details, generating a harmonized image that contains the desired images at the desired locations. How does this work? I'll first describe our desired layer-based image controls in greater detail, then give an overview of the algorithmic components that leverage layers and diffusion models to generate high-fidelity images. Our overall goal is precise control over image output for compositional scenes with several objects. We define this via three subgoals. 1. Harmonization. The output features consistent perspective, lighting, and occlusions. 2. Spatial fidelity. The objects described by the layer text are all generated in the correct regions. For instance, in this image, the ginger is generated in the right place, the edamame is generated in the right place, so on and so forth. 3. Appearance fidelity. Desired visual characteristics of the input layers are preserved. For instance, here the sushi generated is salmon sushi, and the ginger generated is sliced ginger. Now, how can we use layers to actually control the output of a diffusion model? Plenty of things go wrong when we directly apply SD-edit harmonization to the input image. Objects can appear in the wrong place, and they can also look pretty different from how they look in the input image. For instance, the ginger from the left disappears, the rice and sushi appear in the wrong regions, and the sushi doesn't look like what I had in mind. With layer information, we can now control object placement. From every layer, we can extract a mask. For instance, here, the region with color illustrates the mask for the sushi layer. And we can manipulate the cross-attention layers to ensure that the right objects appear in the right places. We do this by upweighting the pre-softmax tensor in the cross-attention layers, with a binary mask indicating where an object should be in the image. And we also downweight regions where the object shouldn't be. We apply this after the QK matrix multiplication and before the softmax operation. With cross-attention manipulation, all the objects now show up in the right places. But the ginger and sushi don't look like what I wanted. I had sliced ginger in mind, not whole ginger. Layer information also lets us preserve key visual characteristics. For the sushi, I might want to preserve the edge maps. By extracting the edge map for the layer, we can leverage a modified version of ControlNet to preserve this information in the generated image. Instead, let's say I want to preserve something more semantic. I can apply textual inversion to the input layer image and capture the core concept of a salmon sushi. And then when I generate an image, I've preserved far more of the desired layer information. In this case, I have salmon sushi and sliced ginger on the right, as I wanted. But maybe I still think the sushi changed too much. What can I do? We let users control how much the input layers can change on a per layer basis with per layer noise levels. This lets us control on each layer the harmonization fidelity trade-off. More noise means more harmonization. These noise levels are converted into a noise image for a blended diffusion style algorithm. Now let's look at some cool results. Here's a scene with a complicated bento box that combines 5 different layers. An indoor scene with chairs, a table, cakes, bookshelves, and a snowy window. Quite a few layers. A bowl of fruit. Here we have to accurately generate apples, red bananas, and red potatoes all in the desired locations without mixing up the objects, even though they're similar colors. Pretty cool outfit. It's an easy way to try on virtual outfits. Just paste the images in each layer of the different pieces of clothing you'd like, and Collage Diffusion harmonizes them together. A bunch of toys. Here we have a teddy bear, a wooden train, and a football. And here a pretty cool example where we have a face made out of vegetables with, I believe, 9 or 10 layers to represent all the different parts of the face. Now let's say that we still don't like the final image we got. Layers are great not just for generation, but also for editing. In this example, in the first row, we've generated 3 candidate bento boxes. But let's say we don't quite like the orientation of the sushi in the box on the first row. We then can basically leverage that as a new starting image and use a modified version of blended diffusion to say, hey, let's take the layer mask just for the sushi, paste the sushi back, and create a new collage, and only harmonize that part of the image. By doing this, we can generate new variants of the sushi while keeping the rest of the contents in the box the same. We then repeat this process one more time, keeping everything the same other than the ginger, and generate different options for the ginger in the third row. Here's the iterative editing process on another scene. In the first row, we make initial attempts at generating the scene with cakes, chairs, a table, a bookshelf, and a window with snow outside. In the first row, we like everything other than the cakes generated. So we take another attempt at generating just the cakes, keeping everything else fixed. In the second row, now everything's looking a lot better. Like, we really like the cakes on the right, but maybe let's take another attempt at the window. And in the third row, we take another attempt at the window and finally get an image that we like. Collage Diffusion is meant to be an interactive system. You can try it out either in Jupyter Notebook form or via our customized user interface. Please try it out. Thank you.